All right, so I've talked previously about the idea of measurement as being quite a man-made thing. We've come up with these units and the equivalence between different units of measurement between centimeters, millimeters, meters, etc. And unfortunately, that leads to a bit of just memorization within this topic and knowing, for example, that there are 10 millimeters in 1 centimeter and all these different relationships. So from my previous video, we have all these kind of basic conversions, but today we're going to be talking about area and volume unit conversion. So you'll see that this is slightly different to the unit conversions we've talked about before. And obviously, I'm not going to give you the unit conversions, although you'll eventually have to memorize them. But I'll hopefully be able to run you through a method which gave me personally a bit of a more intuitive understanding of converting between these different units. So in this particular video, we're just going to run through converting centimeters squared for area or centimeters cubed for volume into millimeters squared and cubed. And feel free to try this with a number of different things, converting from, say, meters to millimeters or meters to centimeters and any other units. But this is just sort of a little way to visualize essentially what we talk about when we think of these unit conversions. So we're going to first talk about the area. Now, these are two identical squares. One I'm going to write in terms of centimeters and one in terms of millimeters. So this is going to be a 1 centimeter by 1 centimeter square on the left here. Now my square on the right has the exact same length dimensions. So our length and our width. But I'm just going to express this in millimeters so we can show how we can go about converting these. So here I have 10 millimeters, 10 millimeters. Now, intuitively, based on what you've observed from previous videos, you'll probably want to say, well, okay, I know that there's 10 millimeters in a centimeter, so converting one to the other for area, well, surely 1 centimeter squared equals to 10 millimeters squared. However, it's slightly different when we work through it because you'll see here that my 1 centimeter by 1 centimeter, if I were to find the area, I would multiply these two dimensions. Or if it was 1 by 2 or 1 by 3 or any other number, to find area, we are multiplying our two dimensions together. So on my left-hand side here, if I were to find this area, that would be 1 centimeter by 1 centimeter. And just in this special case, we're going to get 1 centimeter squared. This won't always be the case, but you can play around with other dimensions and you'll see they have the exact same relationship that we've described. Now, on the other hand, looking at our square on the right-hand side, our units are, well, we have the same lengths, but in different units. So we have 10 millimeters by 10 millimeters. So if we were to find this area, we would have 10 by 10 millimeters. And when we multiply these together, instead of just getting 10, we're going to get 100 millimeters squared. So from what we've observed, we have a relationship that we can make between these two. So we can say that converting from centimeters squared to millimeters squared, we have a relationship that 1 centimeter squared equals to 100 millimeters squared. This is how the unit conversion goes when we deal with area, when we convert area units, because we have two dimensions. We have a length and a width. We're not just dealing with a straight line. So the unit conversions we did in our previous video don't hold up because instead of one straight line, we essentially have multiple dimensions within our shapes. And you can play around with this using different units of measurement. And you would even see, well, converting something from centimeters squared to millimeters squared, we just scale it. We multiply it by a factor of 100. If I were to have, say, 2 along this side, I would get 20 millimeters along this side as opposed to 10. So multiplying those two, I'd get that 2 centimeters squared equals to 200 millimeters squared. Play around with this. I promise it will check out. Obviously, I'm a bit strapped for time because I want to go through area and volume here, but mess around with it, mess around with the different unit conversions. And to confirm that, you can look up on Wikipedia or just on Google, and you'll see that the kind of factors that we've established here for this particular one, as well as the other ones, say meters to centimeters, etc., will all check out. So when we convert from one to the other's area unit will always be increased by a certain factor. So I'll leave the rest to you to play around with. But here I'm going to move on to volume. And we're going to take the same concept, but now we have three different dimensions. We have our length, our width, and we also have a depth here. And we talked about in a previous video, when we find volume, we are multiplying all of our dimensions together to calculate volume. So taking a similar thing, going from centimeters to millimeters, I should say centimeters cubed to millimeters cubed, we have 2 cubes in this case, which are identical. I know it doesn't look like it because my drawing's not the best, but let's just pretend that I'm a perfect artist and I've drawn 2 perfect cubes, 2 that are equal next to each other. So for this thought experiment, we're gonna say that these are equal. So this cube on the left, all of its units are in centimeters. Its length, let me actually write that down here. All of these 3 dimensions are in centimeters. So when I move on to my cube on the right, I have 10 millimeters for each one. I have 10 millimeters here for my depth and 10 millimeters for my height or length. It doesn't matter what we call it. It's just another dimension. So taking this same concept that we've talked about, I'll say, well, the volume of my left-hand side cube is 1 centimeter by 1 centimeter by another centimeter. And I end up with, because these are all 1, I'm going to end up with 1 centimeter cubed here on my left-hand side. Now, you may be able to see, based on how we've done our last example as well, we'd expect, because the volume has one extra dimension, it has this 3rd dimension, that we would expect maybe a higher value for millimeters cubed. Now let's investigate this, and we'll be able to confirm that. But intuitively, you can hopefully see where we're going with this. So we have 10 millimeters by 10 millimeters by 10 millimeters. Okay. Taking this volume, 10 by 10, we get 100. 100 by another 10, we will end up with 1,000 millimeters cubed. And we observe another relationship between centimeters cubed, our volume, and millimeters cubed. So we can say, I'll just make sure I write it in the same way. Okay, from centimeters cubed to millimeters cubed. Cubed to millimeters cubed. We have that for each centimeter cubed, its respective volume in millimeters cubed is 1,000 millimeters cubed. So I've said a lot of cubed and squares, and you're probably tired of hearing my voice at this stage of the video, but these are the two relationships we've established from centimeters cubed to millimeters cubed. So these, as you can see, I've done these kind of double-sided arrows with each of our shapes. This implies that we can go back and forth between these. And you'll see a lot of the questions you'll encounter have this. Now, in the human brain, we don't have enough space to sometimes be able to memorize all of our different conversions. So, off the top of my head, it's very easy to forget sometimes. So a lot of the time, maybe in school or when you're doing these types of questions, you'll have a reference sheet because you're not really assessing a student's knowledge by getting them to memorize these unit conversions. So when dealing with these man-made units of measurement, we can just bounce around between them, and we usually can refer to something. So I'm not trying to push forward this idea of memorizing this, but this is just a little trick, a little way to play around between two completely equal shapes, both for area and volume. And we can see that we can convert our units. So this is in case you just get stuck in a test, you can't remember, for example, the exact unit conversions. We can always draw this little exercise with an area example with two dimensions, two components here, as well as the volume in which we have three different dimensions. Hope that helps. That's a little trick I've used throughout school, and I hope it helps you too. See you next time.